will identify the type of chemical reaction. So here are the examples. Let's get started. Here two elements combine together to form one compound. So the first one is an example of hydrogen combines with chlorine to form hydrochloric acid. That's an example for synthesis reaction, or we can call it as a combination reaction. Second example here, Na stands for sodium, combines with oxygen to form Na2O. So that's sodium oxide, but the hint here is we have to look at oxygen is the supporter of combustion. It helps in burning. So that gives us a hint, like this is an example for combustion reaction. The third reaction, KClO4, potassium perchlorate, breaks down into two things. You see potassium chloride and oxygen. So that's an example for decomposition. Decomposition means breaking down. The next one is an example of zinc combines with copper sulfate to form zinc sulfate, and copper is being displaced or replaced. So what you're going to look at for these type of equations, we need to look at the activity series of metals where elements are placed in the order of their decreasing reactivity. So we are going to look at where the position of zinc and copper, because we need to see where they are on the activity series in order to determine what's going to replace, which element is going to replace which one. So we are going to see that zinc is above copper on the reactivity series of metals. So zinc is more reactive than copper on the series, which is why zinc is going to displace copper from copper sulfate, and as a result of that, zinc combines with the sulfate part and forms zinc sulfate, and copper is being displaced. So here this is an example for single replacement. For single replacement reaction, we need to look at the reactivity series of metals. The last one, NaCl reacts with AgNO3 silver nitrate to form NaNO3, which is sodium nitrate, and silver chloride is formed. So the hint, what we want to look at, NaCl, they are going to swap or exchange their parts. Na is going to combine with the nitrate part, and silver will combine with the chlorine, so forming two new compounds on the product side, that's sodium nitrate and silver chloride. So they exchange their parts and forming two new compounds. This is an example for double replacement. So let's review. The first hint to recognize synthesis reaction would be where two things combine together to form one compound. So that's synthesis or combination. For combustion reactions, we want to look at oxygen. If one of the reactant is oxygen, then that gives us a hint that it could be a combustion reaction. There are exceptions like rusting of iron. We have oxygen, but then that's a different example. Then we have potassium chlorate. When you see one compound breaks down into two or more, here in this case it's broken down into two, that's an example for decomposition. Where a more reactive, now the next one, zinc and copper sulfate reaction, where zinc being more reactive than copper kicks out copper from its solution, combines with the sulfate part. These are examples for single replacement. Don't forget to refer to the activity series of metals in order to determine the reactivity of the elements. The last one here, where you see the they exchange or swap their parts and form two new compounds. In this case, silver combining with silver nitrate, and then they swap or exchange their parts, forming NaNO3 sodium nitrate and silver chloride. These type of examples are double replacement. I hope this helps.